Hi, my name is Will Crawsick, Scientific Services Manager at Chemical Computing Group. Today I'd like to show you how to align the sequences from two or more proteins and then superpose their structures. This would be a useful workflow when we want to compare binding pockets, identify structurally conserved regions, or for homology modelling. So let's get started. So I'm just going to start by retrieving the two structures that we'd like to align and superpose. So I'll just select these two PDB files, hit OK, and I'm greeted with this Load PDB file panel. This allows me to select what data we want to load into Mo. Here, I'll just accept the defaults and we see the two structures appear in the main Mo window. So next I'm going to want to get control of these structures, and for that I'll open our System Manager and pin that to the main Mo window. Here I see our two PDB tags, and if I just click to expand I can see that each includes receptor, solvent and ligand. So I can use the System Manager to hide and show different atom sets, make selections, render and generate surfaces, and here I'm going to do just that. I'll render these according to their PDB tag. I'll just click to center the view. Next, what I'd like to do is introduce the sequence editor. So I can launch this directly from the main Mo window. And as the name suggests, we use this to display sequences. This would also be our launching point to the various protein modeling tools that we have in Mo. Here I find the sequence editor contains the same two PDB tags, and each tag contains protein, a ligand and solvent. In this case we're going to want to align the proteins only, so I'll just click on this minus button. It's going to hide anything that's not a protein, and next I'd like to just customize the view of the sequence editor. And so I'm going to start by changing to the single letter amino acid code. I'm going to wrap our sequence, and I can also control the size of the font. And when I do that, I notice that some of these residues are shown in bold. So this is telling us that we have structural information available for these residues. Conversely, some of these are not in bold, so it's telling us that we know the sequence exists, but the structure for those particular residues are unresolved. So next we're going to want to analyze these two structures, and for that I'll click on the Align Superpose button, which opens the panel pinned to the bottom of the sequence editor. The panel comprises three main sections. The first, Setup Chains button, allows for setting up blocks for group-to-group alignments and subunit assignments of multimers. The middle section is for aligning sequences, and the third section is for structural superposition. Now, in this simple example, we're not going to need any of the advanced options of the Setup Chains panel, so I can move straight to the alignment section. So the objective here is to determine the correspondence between residues of two or more protein chains, and by default we're using the sequence and structural mode. So this uses not only sequence information, in other words the residue identities, but also structure-based information so that we can generate an optimal alignment of the sequences. So I'll go ahead and click Align, and you'll notice our sequence moved, but the atoms did not move in the main Mo window. That's because the Align section of this panel allows us to align sequences. The Superpose section of the panel is used for superposing the structures. So to superpose the atoms, I'm going to go to the Superpose section of the panel. Note that I would have had to align the sequences first, as we just did. So I'll just go ahead and click Superpose using the defaults, and you'll notice that the sequence did not move, but this time the atoms did in the main Mo window. So if I just zoom in slightly, you can see that we've achieved superposition there. We get a readout on the footer here that gives me the RMSD between these two structures. Now, in this particular example, I was using the defaults to try and superpose every residue from each structure. In practice, that might not be the best, because often we're more interested in the binding pocket and or the ligands if they're present, rather than superposing every single residue, including flexible loops. So this case is no exception. I'm just going to change from superposing all residues to just the pocket residues. I don't need to change anything with respect to alignment. We've already aligned these sequences. So I'll just go ahead and click Superpose. And we can see that we get a better RMSD. albeit across just the 31 residues that comprise the binding pocket. If I look in the MAMO window, I see that we achieve better superposition around the binding pocket, but we see some differences as we zoom out. Now, although we've achieved a better superposition, there's still room for improvement. So let's go ahead and look at some of the options available to us that would help improve this superposition. The first is refine with Gaussian distance weights. This option allows us to bias the superposition towards residues which superpose well. The second option is accent secondary structure matches, which biases the superposition of alpha helices and beta strands. So that's going to optimize the superposition of secondary structures. For this example, I'm going to use the refine with Gaussian distance weights option. And again, before I hit superpose, just to mention, I don't need to change the alignment. That's already been done. I'll just click superpose, and we see, if I just go to the MAMO window, we see a near perfect superposition of the hinge region here. And even though the ligands were hidden from the sequence editor, to see good superposition of the core, this canazoline core here, is good feedback that we've achieved good superposition. We did this by placing less weight on the regions that superpose badly, and more weight on the residues that comprise the structurally conserved regions of the pocket. Now from here I can go ahead, click Site View, which is going to isolate the residues within 4.5 angstroms of our bound ligands, and I can start comparing the binding site of these now superposed structures. So that brings us to the end of today's session. Today we learned how to align the sequences of 2 or more proteins and superpose their structures. This is a useful workflow for comparing binding pockets, identifying structurally conserved regions, or for homology modelling. I hope you've learned a lot today. If you have any questions, please do reach out to me at support@chemcomp.com.